All right, so we started looking at 5.4 part 1. And in part 1, we learned a formula to convert between log form and exponential form. And it really is just a matter of moving things around. There wasn't really any math with it. It's just kind of rearranging. Well, we're going to learn a few other properties. And these properties are also something you just have to look for. And when you see this special pattern, the answer is going to be something special. So when we went over the homework, we had a problem where we had a log and the base and the argument were the same number. And we got an answer of 1. That's one of the properties we're going to look at. Another property we're going to look at is when you take the logarithm of the number 1, no matter what the base is. Base e, base 10. Anytime you take the logarithm of the number 1, the answer is always 0. So those are 2 of the 4 properties that we're going to look at right now. Okay, so here's our first property. This is an exponential equation. Right? The way you can tell, you might be confused, like, wait, is it exponential or is it log? Okay. Look at the kind of the overall structure of it. Block out everything that's in the red boxes and just look at what you have. You have a base, you have an exponent, and you have something on the other side. Okay, that's exponential form. No matter what you put in those boxes, it's still exponential form. Okay. And this is a rule to simplify an exponential equation when something very special happens. You have a number, and you raise it to a power that has log in it. But the trick is that the base on the log and the base that you had here have to be the same. That's what makes this property special. And then let's put, let's make up a number there. 12. So this property says that as long as the base here and the base there match, the answer that you get is whatever was sitting right where the arrow is pointing. So if you simplified this one, what do you think you would get?
12.
12. Yeah. The answer to that would be 12. Now, we can do it the long way. We can type that whole thing in on the calculator. 3 raised to the log. Actually, I have to do it like this. 3 raised to the... Takes longer to type it than it did to just figure out the answer. So 3 base 3 of 12. I hit enter, and I get 12. Okay, so it's a shortcut to simplify a problem whenever these 2 numbers match. The answer is what's right there. Any question on that special pattern? Okay, here's another special pattern. This is a logarithmic equation. Okay, and the way you can tell that it's log is do the same thing I did before. Block out everything that's not the word log. We know that that's log form because it has the word log, it has a base, it has an argument, and then it has something on the other side. It doesn't matter that the argument has an exponent in it. That's fine. It's still log form. And the pattern with this one is if these 2 numbers match, then the answer that you'll get is whatever is right there. So if you have log base 4 of 4 cubed. What do you think that would come out to? 3. Yeah, the answer would be 3. And I can type that in again, show you on the calculator, but it's going to take me longer just to type that in than it was to write 3. So we need log base 4 of 4 cubed. Okay, when I hit enter, it says that the answer is 3. So the base.
The base.
We're going to talk more about how you do log base What I did on here will not work on that calculator, but there is a way to do it. I'm going to show you probably tomorrow. All right. So questions on that special pattern? So that's two of them. Now the other two you already saw in the homework. Does anybody remember what happened when we had log base 10 of 10? When those two numbers matched?
This was 1.
The answer, yeah, it was 1.
Wouldn't 1 be the imaginary exponent above A?
Yeah. So, like, if you think of this as log form, right? There's your base. There's your argument. And the logarithm always equals what kind of number?
Positive.
What is it?
A positive.
No, what did we say yesterday? Logarithm always equals the
Exponent.
exponent. So this is your base. That's that one. 1 is your exponent. And what goes by itself on the other side? The argument. So all that this rule is really saying is that if you take anything and raise it to the first power, you always get the same thing back. It's just this is saying it as a logarithm, where this is saying it how you'd see it like in Algebra 1. Anything to the first power is itself. But these two rules are exactly the same thing, just a different way of writing it. Now, we're going to now write this rule as a logarithm. Anything to the first power is itself. What's anything to the 0 power?
1.
1. So that's going to be our last property. Log base A of 1 equals 0. That's that rule right there. A is your base. 0 is your exponent. And the argument ends up by itself on the other side. Anything to the 0 power is 1. So the reasons why all these properties are true, they all go back to things from Algebra 1. The rules of exponents. I wasn't really going to get into why they're true, but somebody kind of brought it up, so that's why I did. But now let's use those properties and see if we can simplify a couple problems. So the first thing to look at is see which pattern or which property it looks like. So the first one is 2 raised to the log base 2 of pi equals x. Which property does that one look like out of 1 through 4?
1.
Yeah, that's very similar to property 1, where a is 2 and x is, we replaced it with pi. So what would you get if you simplify
Pi.
that whole thing? Yeah, you get whatever is the argument to the log function. You get the pi. Well, that's it. So there's no real calculation or anything. You're just kind of looking for that pattern and then following the property. How about B? Which property does that one look like?
2.
Yeah, that one's property 2. So match it up with property 2. Look at what the answer was. And look at what's in the spot where we had an x. What do you think the answer to that one would be? -4. As long as these two numbers are the same, the answer is that exponent. Now, if they're not the same, well, then this property doesn't work. You got to use a calculator. Okay, how about this one? The ln of e raised to the kt. It's a little tricky. And a hint would be, think about what ln means. What is ln an abbreviation for? Yeah?
Natural log.
Okay, so it stands for natural log. How do you write it the long way? Yeah?
Log e.
Log, say it again.
Log with the base of e.
Log base e. That's how you rewrite ln the long way. Log base e of e to the kt. Now it should look like one of these properties. Which property does it look like now?
2.
2. Yeah, it's property 2. So what would that simplify to?
GT.
KT, whatever K times T is. Try one more of those. Let's do log base 12 of 12. That's basically saying 12 to what power gives you 12? 1. Yeah. So that's 1. All right. And then if we did one like log base 4 of 1, that's basically saying 4 raised to what power gives you the number 1?
0.
0. And it wouldn't have mattered if this base was a 4, a 5, or a 13.2. The answer would have always been 0 when you take the log of 1. Okay, any questions on those properties? Okay. So the last thing we look at in this section is properties that we can use to take a logarithm that's all together and split it into 2. Or you can think of it the other way. Take a logarithm that's split into 2 and combine it back into 1. Okay. So here's the idea. If you have a product of 2 or 3 or 4, it doesn't matter. We'll usually do 2. If you have a product of 2 numbers, m times n, you can split that logarithm apart into 2 logarithms. A product always turns into a sum. And it turns into the log of the first number plus the log of the second number. Whether you're splitting it or combining it, the base stays the same all the way through the problem. The base started as A, and it stayed as A. The base never changes. All right, so let me type that in just so you can see it. Let me type in log of 4 times 5. And now I'm going to type in log 4 plus log 5. It's exactly the same thing. Now, 4 times 5 is what? 20. So that's not the only way you can factor 20. What's another way you could break up the number 20?
2 and 10.
You could do 10, yeah, 2 and 10. So if you did log 2 plus log 10, that's also the same. Any 2 numbers here that multiply to give you 20 would work. So you could also do log of 40 plus the log of a half, because 40 times a half is 20. All right, so when you have 2 numbers multiplied together, you can split them apart by adding. Any question on that?
Am I just moving the calculator?
Now that's the rule when you have a product. What do you think you would do if you have a quotient, if you're dividing? Dividing would not turn into addition. What do you think dividing would turn into? Yeah, dividing would turn into subtraction. The order that you subtract is important. It has to be the log of the top minus the log of the bottom. So there's an example with numbers. If you had the log of 4/5, you could write that as log 4 minus log 5. Now remember, this property works for any base. That's why I'm not writing a base here. You could do base 10, which is common number. You could do base E. What's base E again? That's the natural log. Or any other base you want. You could do base 3, base 6. The only thing is, whatever base you start with, keep the base the same for the whole problem. Okay? And remember, if it was a base E, you wouldn't see log base e. What abbreviation would you see? You'd see ln. So you'd see like ln of m divided by n equals ln m minus ln of m. Okay, you just see the word ln. Okay, that's the second property. And the third one. The third property says that if you have an exponent on a log, you can take the exponent and you can move it in front. So if we had log base 10 of 3 to the 5th, we could take that 5, we could put it in front. And the reason why we want to do that is because if the exponent is a variable, it's complicated to solve equations that have variables in the exponent. Well, now we have a way to get rid of exponents in a problem. If you can get rid of exponents, it makes your problem easier. In this case, it's just a number, so there's nothing difficult about that. But the way this would be really handy if it was a letter. Then we could take the letter and put it in front. Any question on that? All right. So with that, there's one thing to remember. If I take the square root of 16, what will I get? 4. Does anybody remember what power you can raise 16 to? And you'll get an answer of 4. So this is a power that means square root, yeah?
0.5.
Yep, the 0.5 or the 1/2 power. Yep. If you raise something to the 1/2 power, it's the same as a square root. So why is that important? Let's say I gave you this. And I said to you to simplify that without any exponents. You might look at this and say there are no exponents. Yes, there are. Okay, square root of x really means x to the what power? Really means x to the 1/2 power. So that square root, it's like it's hiding an exponent. And what did I just say we could do with the 1/2?
You can split that up to log equals.
Well, look at what we did right up above it.
Move it to the front.
Move it to the front. That's the only thing you can do with that.
Sure, you can't split out to the minus and minus.
Nope, because it's not inside the argument.
Okay.
It's an exponent. To split it so it's minus, it has to be the argument itself,
Okay.
not an exponent. Right? So that's the one that can trick people sometimes, because they'll see this and I'll say write your answer without any exponents, and they leave the square root symbol. If you leave the square root symbol, you've technically left a hidden exponent. So you have to put it in front. So that is exactly the same as that. Yeah. Yep, just saying. I just mentioned that. That's what we just did. Okay, so those are the 3 properties that we can use to combine logs together or split them apart. Now we'll try some examples. So it says to separate it into multiple logarithms, and express powers as factors. What that means is do not leave exponents in the final answer. Put exponents in front. Because when you put it in front, it turns into multiplication. That's a fact. So here's our first one. So we have log base 4 of 3x. Okay. When we split this, it's going to split into 2 logarithms. Log and log. What's going to be my base on each log? It's going to be 4 because that's what it was at the beginning. Now, we have 3 times x. When you have multiplication, what does it turn into? It turns into addition. What's going to be my first argument? 3. And my second argument? X. And that's how you take 2 logs, 1 log, and split it into 2. That's it.
You said when it says powers and factors, that means no exponents, you said?
Right. We're gonna do one like that next, where we do not leave the exponent at the top. We move it to the front. Yeah. All right. So let's start with this one. Log base 2 of 5 times r cubed. So we're still multiplying 2 things together. It's that times that. Those are the 2 things we're going to multiply. So when we split it up, it's going to split up into 2 logs because there's 2 things being multiplied. We're going to have 2 logs. What's going to be the base on each log? 2. They're both going to be base 2. And the original problem had multiplication. Multiplication turns into addition. What's my first argument? 5. And we're going to leave it for now, but what's my second argument?
R plus 3. Or R to the power of 3.
R to the power of 3. Now, it said not to leave exponents. So what are we going to do with that 3? Yeah, just in front of that log. Not in front of the entire problem. Just in front of that part of the problem. So 3 log base 2 of r. And that's how you split that one into 2. Okay, any question on that one? All right, let's try this one. Log base 9 of x divided by 2. Okay, so first, how many logs is that going to split up into?
2.
Yep, 2, because there's a top and there's a bottom. So log. What will be the base? 9. It's going to be 9. 9. Now this is a quotient. It's division. What does division turn into? Subtraction. Turns into subtraction. And then my first argument? X. Second argument? 2. There you go. That's how you split it into 2. Any question on that? All right, let's try this one. The natural log of y cubed divided by 8. Okay, how many logarithms is this going to split up into?
2.
2. It's just not going to be written as log. We're going to be writing ln. Okay, it's really log base e, but we don't write it that way. We just write ln. ln and an ln. Okay, we've got what operation inside the argument? Division, and that turns into subtraction. What's your first argument? Y.
Or 1.
Oh, y to the third. Y to the third. We have to fix that, but you can do it in 2 steps if you want. And then your second argument? 8. And to get the final answer, what do we need to do with the 3? Bring the exponent to the front. Bring it to the front. Okay. Any question on that? Let's try the reverse now. So now it says to take 2 logarithms that are separate and combine them together. And the last sentence is the reverse. It says express factors as powers. That means take the numbers in front and put them back as exponents. All right. Do we have any numbers that are in front? 4. Yes. So the first thing you have to do, and this is the last thing you would have done in the other kind of problem, is put the 4 back. So you're going to have log base A of 7 plus log base A. Now, it's going to be 3 to the 4th, but you can simplify that. Just make it a number. What's 3 to the 4th power? 81. Yep. Right. Now, the last step is write a single log. If you've got 2 logs written and you're supposed to be combining them, you haven't finished. You should just have the word log once.
Do we have to do the exponent, or can we leave it as 3 to the 4th, or do you want us to
I want you to do it out.
do it out?
Yeah. Yep. Make 3 to the 4th 81. What's going to be the base when we combine this back into 1? It's going to be an A. Now we have to think backwards, right? We had a 7 and an 81, and it was addition. When we recombine it, that turns into multiplication. And 7 times 81 is 567. And that's the reverse of what we did. Okay, putting it back together. Okay, any question on that? Yeah.
It's just express the exponents though.
Yes, express the factors as powers. So that means to take and move them back up, which we did. But when you move it back up, if you can simplify, you always simplify. Yeah. It's kind of like if it said leave your answer as a fraction and you have this. Well, technically you have it as a fraction, but you can simplify it, so you go one more step. Yep. All right, that's not quite going to work. Let me make this 71. Okay, so we have 2 separate logs, 2/3 ln 8 minus the ln of 3 to the 4th minus 71. Well, are there any variables in here? No. Then I would just do that out rather than having to write it like that. What is 3 to the 4th? 81. So that circled part is really what number?
10.
And 10. So when we go to the next step, let's just make that 10. So that simplifies that. What do I have to do with the 2/3 ln 8?
Bring it back.
Bring what back?
Bring it back to the 8.
Bring the 2/3 back to the exponent.
Yes, make the 2/3 an exponent on the 8.
Yeah.
Yep. Now you can type in 8 to the 2/3 on your calculator. It's going to be 4. It's not critical that you know how to do that. You can really just type it in. But some of them are faster to do in your head than to just type it in. The way I do it in my head is I think of that part right there. What's 8 to the 2nd power?
16.
Not 8 times 2. 8 times 8.
64.
So 64. And then divided by 3 means cube root. What's the cube root of 64?
4.
4. Yeah. That's how I did it in my head. So I did 64 cube root. But you can just type it in. So now we get ln 4 minus the ln of 10. When I recombine that, how many times am I going to write the word ln? Just once. It was subtraction. So subtraction turns into division. What goes in the top? 4. In the bottom? 10. And 4/10 is the same as 2/5. So the natural log of 2/5. Okay. Any Question on that? Okay, so let me just fix this first. We're going to look at a little of 5.5, but I'm going to pause. Okay, so page 292, 13 to 16, and then 21, 23, 25, and then 29 to 32. I think it's 11. It might be like 10 or 11 questions. All right. So the last thing that we look at with logarithms is drawing them. Okay, drawing a picture of what they look like. So we've talked about logarithms that have something like that. And I keep telling you, there's a way you can type that in on the calculator. Now, the calculator can only do two bases by pressing just a single button. What are the two bases the calculator can do? It can do base 10 and base E. That's the button for base 10. That's the button for base E. There is no button directly to do base 3. But it doesn't mean you can't type in base 3. The way that you can type in a log that has any base is called the change of base formula. Okay, it's extremely easy to use. There's actually two different ways you can use it. I always pick one and I stick with the same way all the time. If you have something that doesn't have a base of 10 or E, the way you can type it in on the calculator, one way is to use common log, base 10. You take the common log of the argument and you divide by the common log of the base. So if I have log base 3 of 8, and I wanted to do that on the calculator, I would type in log of the argument, which is 8, and divide by the log of the base, which is what number? 3. That's how you type it in. Let me show you. So log 8. Notice it opened a parenthesis for me. I need to close it. That's log 8 divided by log. It opened it for me again. I need to close it. And that's how you type in log base 8 of 3. And it does make a difference which one you put in the top. Think of it this way. The base is in the bottom. The base is in the bottom, so it goes in the bottom of the fraction. The argument is up higher, so in the fraction, it goes higher. Now, there's another way you can do it, and it comes out to the exact same answer. If somebody superglued your common log button on your calculator and you couldn't use it, well, you can use the natural log button, and it will be exactly the same thing. ln 8 divided by ln 3. It doesn't matter which way you do it. I usually use this one. Any question on it? It's called the change of base formula. Yeah?
It comes out differently when you don't put parentheses.
Yes, it will come out differently when you don't use parentheses because it's not following order of operations. If you don't put parentheses, let me show you what it does. If you want to type that in and you don't put parentheses after the 8, so let's say you did it like this on the screen, what the calculator is going to think you want is this. The ln of 8 divided by the ln of 3. That's what the calculator is going to do if you don't do parentheses. That's not what you want. you
I
want.
got two completely different things. Typing both of those in.
Yes, they're not the same.
Well, no, ln8 and ln3, and log8 and log3 with closed parentheses.
As long as you put your parentheses exactly like that, and you put in the same numbers, you'll get the same answer.
That's not.
Did you put the divides in?
Yeah, something's different then.
Something's different.
Has to be. Let me see.
Oh, that's what I thought.
You did something, yeah.
Yeah.
Something has to be different. What if I asked you to find this? Log base 5 of 2. If that was a problem on last night's homework, we would have went like this. Right? We would have put equals x, because we wouldn't have known. How do you write this in exponential form? What's your base? 5.
X equals
What's your exponent?
X.
And what's your argument? 2. So when you type this in, which I'm going to ask you in a second, onto the calculator, you're really solving for 5 to what power gives you the number 2. That's what you're trying to find. So how do you type this in on a calculator so you can figure out what that exponent is?
Log 5
Log, yep.
over log 2. No, wait.
Look at the way it's written. 5 is lower, 2 is
Oh,
higher.
Log 2 over log 5.
So keep the 2 higher, keep the 5 lower. Just like that. So let's see what it is. Log 2 divided by log 5. It's about 0.4307. So now try it. Raise 5 to the 0.4307 power. 5 raised to the 0.4307. I got 2.000007. How come I didn't get 2?
Probably because it rounded the 07 up.
Yeah, because I rounded the answer to 4 decimal places. So whenever you do, or whenever you use logarithms, the answer that you get represents an exponent. That's always what you're solving for with logarithms. Solving for an exponent. Just now, you know how to type that in. And that'll work on any calculator. You don't need a Graphng calculator to type in something like that. Right? Any calculator that has a log button on it can do it. All right, now let's graph. Find a complete graph. So, and the domain and the range. Okay. Does the calculator have a button for log base 3?
Oh, saving that. Wrong class. Thank you.
You're welcome.
58.
Does the calculator have a log base 3 button?
No.
No. Then you're going to have to write it so you can type it in. The only way to write it is to make it a fraction. How do I turn this into a fraction that I can put in on the calculator?
It would be log X divided by log 3.
Yep. 3 was lower, keep it lower. X was higher, keep it higher. All right, so let's graph that and see if we can figure out the domain and the range. When you type it in, I would do it like this. Log X, close the parenthesis, log 3. It's not critical you close the parenthesis after the 3 because there's nothing else coming in the problem. We're done. But I would be closing. Now, the calculator doesn't do a great job sketching this. Let's see what it does. That's not really what it looks like. All right, let's get that graph. Let's go to the table. Okay, it's fine going to the right. That part looks good. But it's when you get close to the origin that that's not what it should look like. Okay, so let's put that on ask. Now, I can't do 0. That's an error. I also can't do negative numbers. I think I mentioned yesterday, when you take the logarithm of a number, it has to be bigger than 0. Okay? So the graph doesn't go past the y-axis. But let's try, well, just look at that graph. If you looked at it and believe what you see there, how low does it look like it goes? Looks like it goes to -2. All right. Well, let's go to zoom. Let's zoom in. And let's see if it really looks like it's at -2. Does it look like it's at -2 now? No. What does it look like now?
-3.
Now it looks like it's -3. So the calculator's not doing a good job of showing what's really happening there.
Just goes down.
It just keeps going down. If x is extremely close to 0, and I hit enter, right? It says -18. So it is going way down. It's just the calculator can't draw it. So what this should really look like is that. That's your picture. Okay, so let's look at the domain. How far to the left does the graph go?
Anything greater than 0?
Anything greater than 0. So does it reach 0? No, doesn't reach it. And how far to the right is it going to go? Infinite. That's the domain. Yep. And how about the range? What's the lowest that it goes?
-3.
Yeah, it just keeps going down. And what's the highest it's going to go?
Positive infinity.
Yeah, it's going to keep going up. I mean, it's going to be extremely slow, but it's going to keep going. And that's something that applies to every log function. The range is always all real numbers. Doesn't matter if you flip it, shift it up, shift it down. You can't change something that goes forever left and right. Now, the domain, could you change that? What do you think, Alex?
Yeah, if you shifted it.
Yeah. If you shifted it left or right, like if you shifted it right 2 units, it might look something like that. And now the domain would be 2 to infinity instead of 0 to infinity. So yeah, you can shift it left and right. Any question on that, especially how to type it in on the calculator? Yeah.
I just have a question. On the test, does it matter if we put all real numbers or negative infinity to infinity?
Most likely it would be like a match. So I would ask you to like pick which one it matches. Okay. So you'd have to know that that means all real numbers.
Okay.
If it was a blank box where you could type in anything, and I didn't say how to write it, either one would be fine. All right, I think transformations will be good. We're actually almost done, but we'll finish tomorrow. So let's do the transformations. Transformations for logs work exactly the same as every transformation we keep studying all year. So I've got the A, the B, the C, and the D. And what we'll do is describe each one of them. And then try an example where we look at the transformations. Okay, let's start with A. A is addition, and it's inside the parentheses. What kind of transformation is A?
Horizontal. Horizontal shift.
Horizontal shift. Yep. Plus is going to move it which way?
To the left.
It's backwards. Yep. Plus is to the left. And minus?
To the right.
To the right. Okay. What about B? That's still inside the parentheses, so it's going to have something in common, but it's multiplication. So it's a horizontal, but it's a stretch. And remember, that one is backwards as well.
Stretch or shrink or just stretch?
It could be a stretch or a shrink, but it's backwards. The bigger you make the number, that's a shrink. The smaller you make the number, that's a stretch. So it's like if you did like log of 10x, you might think, ooh, 10's a big number, it's going to make it bigger. No, that's actually going to compress it 10 times as much. Versus if you wanted to stretch it 10 times as much, you would do this. A small number stretches it bigger. A big number compresses it smaller. So it's backwards. Right? What about C?
Vertical.
Right, now we are outside the argument. When you get outside the argument, now you're in the vertical. And it's multiplication. So it's a vertical stretch. And that is not backwards. With the vertical stretch, if you put a big number in for C, it stretches it bigger. If you put in a small number for C, it compresses it smaller.
Isn't it less than or greater than 1?
It's, yeah, greater, less than 1 or greater than 1.
Just wanted to make sure.
So if you do 5 log x, that's a vertical stretch by a factor of 5. If you do 1/3 log x, that's going to compress it by 3. Right, and what about D? Vertical shift. And this one, again, is not backwards. So positive would move it up, negative, down. The only other thing that can happen, B and C could be negatives. And what does that do if B is a negative?
Reflection.
What kind of reflection?
Over the line.
Yep, that's a horizontal reflection. So that could happen with the horizontal stretch. And what if C is negative?
Over X.
That's-
Over the X-axis.
That's a vertical reflection, which is over the x-axis. You could just say vertical reflection. Or you can say over the x-axis. Same thing. So there's 6 things that could happen. 2 shifts, 2 stretches, 2 reflections. Usually you don't have all 6 in the same problem. All right, so let me leave that up. Let's try this one. Whenever you compare 2 functions, these are always going to match. You can't compare a base 4 log to a base 3 log. It doesn't work that way. You can compare a base 3 to a base 3, base 2 to base 2. Bases have to be the same. All right, so when you write the transformations, follow the order. Start with A, then go to B, then C, then D. If you're missing one, you skip it. Do we have anything for A in this case?
No.
No. So you could think of it as like you've got a plus 0. There's no A there. Do we have anything for B?
Negative.
We have a negative in place of the B. So what is that negative going to cause the graph to do?
Horizontal reflection.
Yep, that's going to be a horizontal reflection. So let's start with that. So 1, horizontal reflection. Okay, so there's the transformation. Now let's type it in, because they want to know the domain. Well, the range I think we could do right away, because I already talked about the range. Every logarithmic function has a range of what?
Negative 50 to positive.
It's always negative infinity to infinity. I don't care how you flip it, stretch it, or shift it. The range never changes. But can the domain change? What do you think? Yeah? You have a guess? You think so? You sure? Okay, yeah. The domain can change. So let's type it in. I think we pretty much already have it typed in. What's the only thing that I have to change from what I have in Y1 to type that in?
You have to make the x negative.
Just make the x negative. And remember what that negative is going to do. It's going to reflect it horizontally. So before, it looked like that. This one is going to look like that. It's going to go the other way. Let's try it and let's see. So make the x negative. I should zoom out though. So let's do zoom 6. Remember, it's not going to do a great job of really showing what's going on. How do I need to fix that graph? So it actually shows what it really looks like.
Just add the asymptote.
Yeah, just add the asymptote right here. Remember, it gets closer and closer to the y-axis. It never touches it. It just gets close to it. Okay, so what's the domain there? How far left does it go? Yeah?
Negative infinity.
Goes to the left forever. And how far right does it go?
To 0.
It goes to 0. Does it reach 0?
No.
No, never reaches 0. So the fact that it never reaches 0 answers that question. The vertical asymptote is what you get very close to, but never reach. How does the equation of a vertical line always start? X equals. And what are we getting very close to but never reaching?
0.
We just described it in the domain. Yep. So that's your domain, your range, your vertical asymptote, and the transformation. That's everything there. Okay, so any questions on that? All right, so we still got just under 20 minutes left, but I think that's a good place to stop. So tomorrow, we have four slides left, and we'll finish up tomorrow. It's going to be some of these problems from page 301. We skipped 293, so you can write that down, but I might tweak it a little bit. So it's a good idea to hold off. Because I might change it. So the only one you have to do for tonight is I'll put it back on the board right now.
All right.
Yeah. All right. So that's the only homework you have for tonight. 5.5 we'll finish tomorrow, and we'll have our first test for term 2 on Friday. I will be after school. Remember, you can make a reference sheet if you want to, and you can use it on the test. Any examples, any notes, whatever you want to use. It just has to be one sheet, but it can be front and back.
Will you put test topics
Yes.
in Schoology?
Tomorrow, when we finish the lesson, I will do the test topics. It will not be in Schoology, but it'll be on YouTube.
Okay.
No.